Let's talk about power. Sorry. So power, remember that power is literally work divided by time. It's how many joules of work a system does divided by the seconds, right? Now remember, watt is the unit of power. Okay. So I can't tell whether you're laughing. All right. So let's derive an equation here just for kicks, okay? So work is going to be work divided by time. Remember that work is Q times V, right? So QV over time, right? And then if I just put parentheses there, Q over T is I. And so our first formula is that power is current times voltage. That's kind of fun, right? Okay, so if you have 10 amps flowing and it's 120 volts, that's 1,200 watts of power, right? So if you have a hairdryer and it's 1,200 watts, that's not too uncommon, right? There's 10 amps of current flowing. That's why those little cables, that's about all they can carry, those little wires that you plug in, right? 10 amps is a lot of current. They get warm, okay? Now let's make the rest of the formulas just for kicks here. We've got P as IV. Let's do a substitution for I. Isn't I, from Ohm's law, I is V over R, isn't it? Okay, so it's V over R times V. We get V squared over R. Ta-da! So power, that's power, right? So that's one other equation. Here's one. Here's two. And then let's do P is IV. Let's get rid of V. So V is IR, right? From Ohm's law, V, from using this, right? V is IR. So I'm going to go I times IR. And it's I squared R. So these are our three useful formulas for power, okay? Current times voltage, voltage squared divided by resistance, current squared times resistance, okay? There it is, it's erased, right? And then they're all in the data packet just like that. So you're all set. Let's do the example problems here. Car stereo uses 850 watts of power. How many amps does it use at 12 volts? Well, if you're thinking about this, the lower of power is IV, right? Right? The lower the voltage is, the more current you've got to use, right? Yeah, and this is one reason why they transmit electricity at super high voltages, is to cut that current way down. But with a car, we just have 12 volts, right? So I'm going to go P is IV, right? So therefore, I is P over V is 850 watts divided by 12 volts is divided by 12. That's 70.83 amps. Now, the interesting thing is that a alternator can only put out about 50 amps of current, right? And so you either have to, you could draw this much current, you can draw like 300 amps from a battery short term, right? It's just that the alternator can only put about 50 amps, coulombs per second back in the battery. So you could either use this for a short period of time, right? Or you could, until the battery runs out, right? Or you could have multiple alternators. So the people that have those giant, huge stereos, they're probably about 850 watts or something like that. They've got more than one alternator. It's a custom job. You can't just plug it in. All right, let's see. You have 128 milliamps of current running through a 560 ohm resistor. What power will it dissipate? What's the voltage across it? Ooh, we can do this. Okay, so power is IV is V squared over R is I squared R. And of course, I'm going to use I squared R here because I have I and I have R. Okay, so I'm going to go 0.128. squared. So that, remember that, notice that's milliamps, right? So, and then times 560. Milli means 10 to the minus 3, so you're going to go boop, boop, boop. All right, so 0.128 squared times 560. And I get that it is 9.175 watts. Watt is the unit of power, right? Okay, and then we say the power dissipates, right? The voltage is across things. Voltage is across, current flows through, and power is dissipated. You got to get the right vocabulary, right? Dissipate means to go away, to like go off in the air or something like that, right? Okay, so let's see. What is the voltage? So V is IR. V is IR. I'm finding the voltage, right? And the I is 0.128. and R is 560. So 0.128 times 560 is 71.68 volts across it. Alrighty, I think that's it, baby.